Good day, everyone. We're speaking from Palo Alto and from Oakland, California, and from Israel. So have a good day, good morning, and good evening. In today's session, we're going to cover Scylla's new open source Amazon DynamoDB-Compatible API called Project Alternator. Before we get started, we'd like to review a couple of items. We welcome your questions. You're welcome to use the Q&A button located at the bottom of the viewing screen and ask any questions. We may be able to address the questions as we go or towards the end. As we do the webinar, it's relatively harder to see those questions pop, but we'll try our best. The webinar today is recorded, and the link to the recording and the slide will be sent later on following the event. So let's get started. I'm Dor, the co-founder of ScyllaDB and the CEO. Along with me, we have Avi, our co-founder and CTO, and Nadav Har'El, who's the lead engineer on the Alternator project. You can have our bio here. The three of us have been working together for quite some time. I think that Nadav, if I'm not mistaken, is the second engineer and the second hire at Scylla. So quite long time here. And even before, we were all working on the KVM hypervisor project, and Nadav was working on nested virtualization, one of the most sophisticated features of virtualization. And today we're about to address nested documents, so kind of Nadav is our nesting expert. So today we're going to cover a Project Alternator by Scylla. If you do not know what ScyllaDB is, you're probably logged into the wrong webinar. So we're a NoSQL database company. We address real-time big data use cases. This is where we shine the most. We have compatibility with Cassandra and now with DynamoDB API. Usually we provide 10x the performance, mixture of throughput and latency. You can consume Scylla as open source, as enterprise offering, and recently, relatively new, earlier this year, we published the Scylla Cloud, a database as a service. And we have plenty of good customers and users and plenty of great data and use cases on our website. In today's agenda, we'd like to make it as much as hands-on as possible. So we'll briefly describe what is Project Alternator and really basic advantages. There is lots of material that was published, so we won't take you through everything that was published and try to concentrate on the actual demos and differences between similarities and differences between Scylla Alternator and the original DynamoDB, and eventually give you a link to how to migrate between the two, because migration is just ready, and you can just, the best thing after the takeout after this webinar is that you can go ahead and run it yourself. It's trivial. Avi, please explain what is the alternator.
Thank you, Dor. So I assume you're all familiar with ScyllaDB and DynamoDB to some degree. And ScyllaDB brings a huge cost efficiency advantage and great tail latency. And on the other hand, DynamoDB is heavily used by applications on Amazon, on AWS, and Project Alternator brings the ability to run applications that were written against the DynamoDB to just run them on top of Scylla, and so enjoy these advantages of performance and cost efficiency. And it does that by adding a new front end to Scylla. So in the same way that Scylla has a front end that serves the CQL protocol and also a front end that serves the older Thrift protocol, there is now a new front end that serves the DynamoDB protocol, and that is called the Project Alternator. And Nadav will explain the rest.
Okay, okay, so let's look at what are the principles that Scylla is designed with, and why we decided to also add the DynamoDB API. So the primary design goals of Scylla was, first of all, to have a very efficient implementation on modern hardware. So modern hardware has many cores and has very fast and parallel SSDs. And so we wrote Scylla in a way that can actually use this hardware in an optimum way. And we got a throughput which is 10 times better than Cassandra had. And we have very low tail latencies. And we gave a lot of attention to the reliability of the database and also making it very autonomous. So it makes decisions on its own on what to do in the background and how much and so on, instead of having to be configured by the user. So all these great design principles we have now in Scylla, but are just for the Cassandra API. So it would have been really nice if we could have all these advantages also for other things. So we decided to start with the DynamoDB API. And if you're wondering why, there are several reasons why it's a good thing to have in Scylla. So the first thing is just that DynamoDB is relatively similar to the data model and design of Scylla, and this is related to the fact that both of these systems were inspired by Amazon's original 2007 paper about Dynamo. Now, there are quite a few differences, and I'll cover them in a few minutes, but there are also a lot of similarities that come from this original inspiration from 12 years ago.
So this is a sort of a family tree of databases.
Yeah. So the second reason why it's good to have a DynamoDB API is that DynamoDB is a software as a service. You don't install it, you just run it as a service. And so it's very easy to get started with, and it has become a trend in the industry. And you can see here a graph of the popularity of DynamoDB versus Cassandra over the last few years. So you can see DynamoDB is growing much faster than Cassandra is. So there's a lot of demand for DynamoDB and its APIs and applications. Another reason why you might want to have DynamoDB API in Scylla is that last year we did a benchmark. We took a use case and ran it on both Scylla and on the managed Scylla cloud. And we also ran it on DynamoDB, the same use case. And we showed, you can see here the link for all the details of the benchmark, but we showed that Scylla is five times cheaper than DynamoDB. Actually, this was the smallest difference we saw. We had other cases where it was even bigger difference between the prices. So having a DynamoDB API on Scylla can also save users a lot of money. And the fourth reason why you might want to have a DynamoDB API is to avoid vendor lock-in. So currently, if you use the DynamoDB API, you have to use Amazon's AWS. And if you want to move your application to a different cloud provider or a private data center or some hybrid of all these things, you can't do this just with DynamoDB. So Scylla will help you do this because you can run Scylla on any cloud or data center, and if it has a DynamoDB API, it will help you run these your applications. So after the introduction to Alternator, let's go to see a few live demos of how it works. So let's just start with how you can get started with Alternator in 5 minutes on your own machine. You can use Docker to just get it up and running in 5 minutes and see if your application actually, how it actually works with Alternator. So I'll show you how I run it. So, okay, so I'll just, so I will run just Docker run and give it the name of the image. And basically this image just contains Scylla. It's a normal Scylla, but you need to add an option, alternator port equals, I lost a digit somehow. Just a second. Okay, I don't know, I'll start it. I think that I got the right number. So this is starting. If it's the first time you do this, it will take a couple of minutes to download the image. It's not a very big image. It won't take a long time, but I've already have it already cached, so it didn't take time to download. And now I can look at the logs.
You have a typo.
Yeah, I don't know what's going on. Okay, so you can see that this is the Scylla logs, the normal Scylla logs. You can see all sorts of normal Scylla events. It does compactions. It also, this is the server that usually listens to CQL. And now you can see that it finished the initialization, and Alternator is listening on port 8000 like we wanted. So now we can just run any application that does DynamoDB API requests and just tell it to go to this port 8000. So as an example, I have Amazon has the AWS command, this command line interface for all sorts of AWS things. So here's a command to the AWS command that does DynamoDB create table. I want to create a table called my tab, for example, and I have to tell it, of course, where is the endpoint URL. Instead of telling it to use the actual AWS, I want it to use this IP address and port that I'm running on my Docker. So I will run this command. And you can see it worked, and the reply is a JSON document. This is the DynamoDB API. Both the requests and the responses are JSON documents. And you can see in this response that indeed it created a table called my tab, and the table status is now active. This table is now exists. And if, for example, I just try to run the same command again and create the same table again, it will fail because you can't create a table that already exists. So it's nice, this create table command actually works. And if you want to see that it's actually a real Scylla with the real CQL, so I just run the CQL-sh command. Just a second. Yeah. So I'm connecting to this Docker image, the Scylla running on the Docker image with CQL-sh, and I can use the alternator key space and scribe tables. So you can see there is the my tab table. It was created, and I can describe table my tab and see this is an actual table in Scylla.
So in fact, you can access it, the same table, from multiple protocols. If you have any need to do so. Usually you would only use it with one protocol, but it's the same table and it's available using all of the protocols that Scylla supports.
Yeah, I just wanted to emphasize that it's the same database. It's not some other product or something. It's the same software that does both of these APIs. Okay, so this is what it did. Yeah.
And even to reiterate, because even if we say 2 times, 3rd times, maybe it's the charm, it's the same binary, one binary inside that Docker image. So it's relatively super simple to run it at single configurations, transform a Scylla server into a DynamoDB API, and you have the two to use.
Yeah. Okay, so this example I now ran just had a create table request, so it's not very convincing. Maybe, I mean, you can't get convinced that we support all the DynamoDB features, so we I wanted to show you something uses a lot more DynamoDB features. So what I did is I found an example DynamoDB application that actually Amazon wrote as an example. That it's a tic-tac-toe demo. It runs a web server that lets many users connect to it and then invite each other to play games against each other. And of course has to keep the state of each game and whose turn it is and all sorts of, it has to do a lot of interesting things in the database. And it uses a lot of DynamoDB's features. It has secondary indexes and it has conditional updates and all sorts of types of things. So this is an interesting example because it uses a lot of DynamoDB features and Amazon themselves wrote this demo. So it's nice to see that it actually works on Alternator. So I'll show you how it works on Alternator. So I opened the wrong window. Okay, so this just runs, the application is written in Python and it uses the Boto3 library, the client library, which Amazon wrote. So now we have this application. Just a second. Okay, let me start from the beginning. Okay, so I have this game server. I have to log in, and now it tried to connect to the Alternator database, and it saw that the table doesn't exist yet. So you have a button create table, and it will create the table. And now I can create a game. So I'll choose Avi as an opponent. I hope I can beat him.
Thank you. It is my honor.
Okay, so now you can see that it started the game, and it's telling me that actually Avi's turn. So I can't play now. If I try to play, it tells me it's not my turn. Of course, it found in the database that Avi didn't play yet because it doesn't really know this web application doesn't know anything without the database. So let's, okay, and here too I have to, yeah. Okay, so here, this is another window, just another window, so it'll have a different cookie, and I log in as Avi. And now Avi sees that he can, of course, create a new game, but he sees that he has a pending invitation for me. I'm NYH, so he can accept this game, for example.
I accept the challenge.
Now it's his turn. So
okay, let's see if all the years of practice paid off.
Yeah, and so he played, and you can see that he can't play again or anything like that. And when I go back to this is again my screen, NYH, you can see that I can already see the move that Avi made, and I can make my own move. So let's not finish this game, but
we will finish it later.
Yeah. Just a second. So the important point is not that you can use Alternator to play tic-tac-toe. You don't need Alternator to play tic-tac-toe, but the important point is that we can run fairly sophisticated applications which were written for DynamoDB on top of Alternator.
And this is without any change to the application?
Yeah, it's just the Python program that we downloaded from Amazon and just ran it. It's not no change at all. Just you can see here the parameter. You have to give it the parameter of which port to connect to, but that's it.
And we received the question from the audience and whether all programming languages are supported, and the answer is yes, because the protocol is the same, the wire protocol over HTTP and HTTPS, so it's agnostic to the programming language. Yeah,
and it's the protocol. I'll show in a few minutes more about the protocol, but also you have a lot of client software written by Amazon, so they have it for all sorts of languages. You can just use exactly the same drivers you would use to run against DynamoDB. It's exactly the same application you can use. Okay, so this was tic-tac-toe demo.
And although tic-tac-toe looks like a very simple application, it does use secondary index under the hood. So it's a nice demonstration of simple but complex under the hood. But we didn't need to do anything special to run it.
Yeah, so these were like small demos. Now I want to show a much bigger demo, so something we have running right now, and we want to show how to monitor it. So Do, you want to say a few words about the monitoring capabilities in Scylla?
Yeah, quick word about monitoring, and Nadav will demonstrate it soon. It's super nice that you'd be surprised as a service database, why would that require such a more complex and a lot of insight with monitoring? And the reason is that although even if you consume a service, then you still want to know a lot of things about how the database behaves as a function of the client operations, especially for a database, because there are complex operations. Some operations, not all of them are the same. Some small command can generate a huge reply. So you do want to know how your database behave and get as many insights as possible. And since we're using the best of breed open source components, and two of them are Prometheus and Grafana, and they give you a big advantage of using standard tools. So you can even correlate and build your own dashboard and have your application metrics together with the database metrics and over the same screen, and then correlate how the two behave and learn from that. And also, it provides you ability to figure out everything that the database is doing. So let's switch to the example and cut down the words.
Yes, so what you're going to see now is an actual live run that is running right now. So we have a cluster of 3 very big nodes on AWS, 30 core nodes each in a separate availability zone. And we have there already 1.1 terabyte of data, which is 1 billion items, each 1.1 kilobytes. And we are running a YCSB workload with 50% reads and 50% writes, and a Zipfin distribution. And let's see the live monitoring. Not this window, just a second. I have to, okay, so it's that window. Let me go to the top. Okay, I'll start with the whole cluster. Okay, so you can see here we have a cluster of 3 nodes, which are all reachable, like the 0, unreachable, and all sorts of like statistics that we have here. And you can see here the current, the machines are currently almost loaded. We have a lot of, I think we have like 18 machines sending load. And you can see the server is almost fully loaded, 75%, the 3 servers, I mean. And the total number of requests that we are handling each second is over 100,000 requests per second. If you go to the DynamoDB pricing page and you see how much you'll have to pay for to Amazon, if you were to pay for 100,000 requests per second, you see that it's a really big number. I didn't actually do this calculation. I'll show a few prices later, but it's really impressive to get 100,000 requests per second with the DynamoDB API. And let's switch. So this was the entire cluster. We can also show, for example, per instance. So this is for each of the 3 nodes. You can see that each of the 3 nodes has a different load. It has a slightly different number of requests per second. And we can also show by shards. So each node has 30 CPUs. So you can actually see the number of operations that each of these CPUs does every second. And sometimes it's important this information can help you find some hot keys and things like that. So all this information that you can easily get is sometimes very useful. So this was the number of total actions. Just a second, I switch to the per instance. Why not switch?
It's reloading. It takes a little bit of time.
Yeah. Maybe I can talk while it's thinking. So, yeah. So you can see a lot of other things in this monitor. We have a lot of different panels. I'll just show you a very few things. So for example, I can see how many requests per second for different types of requests. So this, I told you this workload does 50% reads and 50% writes, and you can see here, I wasn't kidding. It's really the same number of update item and get item requests per second. And let's see another interesting thing. I'll show you. Here's another nice graph that you can see. For example, the number of cache hits versus cache misses over time. So we actually started this workload just 20 minutes ago or so. So you can see that it started, when it started, we had the cache hits were low and we had a lot of cache misses. And now as the cache gets warmer, we actually, the number of cache misses goes down and the number of cache hits go up. And we have a lot of other panels and a lot of other metrics you can see, but we don't have time to cover all of them, but it's a lot of, it's a very powerful feature to be able to understand exactly what's going on in your database. Okay, so I'm going back to the presentation. Okay, so now I want to go a bit about the Alternator's implementation. I don't know, Dor, do you have questions in the background? I can't follow the questions. Or I should just continue?
There was a question about whether someone can see the latency, and the answer is yes, you can see the latency per operation.
Yeah, all sorts of percentiles of latencies. You can see the mean latency, the 95 percentile, 99 percentiles, all sorts of statistics on the latencies.
And there's a different question about, I'll answer, well, we can wait them towards the end, about autoscale, how it's handled. So basically, just all of the nodes in Scylla are homogeneous, whether we serve CQL or whether we serve a DynamoDB API. With DynamoDB, there's certain difference with the DNS that we'll cover later, but there is no single point of failure for the question.
Okay, so I'll continue. If we have more questions at the end, or maybe I'll already answer some of these questions, and let's continue. So now a bit about Alternator's implementation, and I want to look at some of the similarities and differences between Scylla and DynamoDB, and how we handle these differences and what we still need to do before this becomes a generally available product, because right now it's considered a preview. It's not yet in an official GA version. And there is a link here to our design document where you can see a lot more details about the different differences and similarities between DynamoDB and Scylla. So first, just a few similarities. So both of these databases are fast, scalable NoSQL databases with real-time responses. Very fast response and huge volumes. They do key value stores and wide row stores. You have eventual consistency, and also you can configure higher consistency levels. And both of them store data in partitions, which are located according to a hash function. And inside each partition, you have items which are sorted by a sort key. So these are things which are similar in both databases. Of course, the way you use DynamoDB and Scylla is quite different. So DynamoDB is cloud native. It's part of a service. It's not you can't install it or something. It's a service. It's part of Amazon's huge deployment. You can't move it to any other cloud or your own data center or whatever. While Scylla gives you a lot of different options of how you can use it. It's open source software. It's also you can also get an enterprise version which is supported, and it's also we have the Scylla Cloud where you can get Scylla instances as a service. And you can run it everywhere. It has a lot more configuration options than DynamoDB. So if you want, for example, a different number of replicas, then you can in Scylla. As Dor said, it integrates with other open source projects for monitoring and so on. So it's very convenient in an open source like environment. And the way you provision things in Scylla and DynamoDB is different. In Scylla, you usually talk about servers, but in Dynamo, you talk about number of I/O operations per second. And the API is different. The Scylla uses CQL and Dynamo uses HTTP requests and in JSON format. I'll give you an example in a few minutes. So now let's look at some other things which are similar or different in between Scylla and DynamoDB. So the data model I already mentioned before. So both of these, so these are the similarities. So in both systems you have tables, and the tables have partitions and items in them, and these are the same things in Scylla and DynamoDB. And you have the hash key and the range part of the key. So these were all similarities. And the key columns, were the columns which are part of the key, you have to define the type in advance in a tables schema. So this is true for both of these systems. But now there is a difference. The difference is the rest of the attributes in the item. In DynamoDB, they are not defined in the schema. In Scylla, they are defined in the schema, but in DynamoDB, they are not. And in DynamoDB, each item can have different attributes with different types, and you have all sorts of types. You can have scalar types like strings, numbers, and so on, and also more complex things like sets, lists, and nested documents. Basically, the item in DynamoDB looks like a JSON document. It has a nested structure, and so this is not something which Scylla was originally designed for. So we had to emulate this in the data model that Scylla does have. So what we do is we put inside each item, which in Scylla is called a row, we put a map, and the map maps between top-level attributes and the value, which is a JSON subdocument. And this is better than, another option would have been just to keep the entire JSON document as one column inside Scylla. But the nice thing about having a map is that it allows the user to do concurrent updates safely to different top-level attributes of the same item. So this is why we did it this way. And something we still need to finish before the GA is to allow updates deep inside the JSON documents, which is currently not done yet, but we will do it. And we notice that it's not, most applications don't do this, but to support the DynamoDB API, we have to also implement this. Okay, another difference between the way that DynamoDB and Scylla work is the way that writes, updates or writes actually work. So DynamoDB has native support for read, modify, write updates. So these are updates which need to both read and write, to read the existing value and then modify it somehow and then write it back. So DynamoDB has conditional updates. So you can say you want to set A to 2 if A is currently equal 1. And you have counters, you can increment, for example, you have copying attributes. So DynamoDB has this feature natively, while Scylla actually focuses on writes that don't require a read, because that's one of the big advantages of Scylla, that when you do writes are very efficient. And you can see in the pricing of DynamoDB that writes are much more expensive than reads, but in Scylla, the writes are very efficient because they don't need a read. So what Scylla instead supports is the ability to independently write concurrently to several columns and have it be fine at the end. This is called CRDT, conflict-free
replicated data type.
Yeah, replicated data type. So this is a difference between how Scylla and DynamoDB works, and the implication of this is that if your application currently needs these read, modify, writes and needs to do it concurrently and safely, I mean, isolate these different writes, then the current version is not good enough for you, but we are now adding support for read, modify, write operations to Scylla, and this feature is called LWT, lightweight transactions. So we are now adding this feature, and this will also be in Alternator. And if you're curious why this difference in focus, it's basically based on the different implementation in Scylla and DynamoDB. So first of all, the files inside one node. So inside one node, Scylla stores the data in a log-structured merge files, if you're familiar with that. But the idea, the benefit of this approach is that it allows you to do writes without needing to read the previous data. While in DynamoDB, they're using a B tree, which while you're doing a write, you're actually going to the same place where the data is already located, so you can also read this previous data. So you're getting a free read with the write. This is why with this implementation, it's very natural to have to allow all these read, modify, write operations. And also for the distribution of the data, there is also a difference which is relevant to these read, modify, write operations. So Scylla has consistency based on quorums or other consistency levels, and you basically do the writes independently on different replicas. So, sorry about that. So in Scylla, you do the writes separately in each of the replicas, while DynamoDB uses something called a leader model, where you have several replicas, but one of them is responsible for doing writes. So all the writes go only to this leader, and it can serialize the different read, modify, write operations and ensure that they don't happen in parallel.
Nadav, if you're choking, we have also replication of 3 in this webinar. So, but continue with the leader model as before.
Yeah, so I have some water here, so I'm better now. Okay, so this is the reason why this difference happened, that Scylla focuses on writes that don't need the previous read, while DynamoDB focuses on writes that do give you the previous value. But although this difference exists, we are working on adding this feature also to Scylla, which is called LWT, which is mentioned in the previous slide. So now this is something that Dor mentioned earlier, that So how does the server, so we have to answer all these DynamoDB requests. So basically what happens is you have a lot of Scylla nodes, just like you have for CQL, so you also have them for Dynamo. And each one of these nodes also answers requests for the DynamoDB API. We don't have a separate layer of proxies or anything like that. Instead, the original Scylla nodes also answer requests for DynamoDB, and the benefit of this is you don't need to do separate sizing for this. If you have proxies, then you always have to worry, do you have enough proxies? Maybe you have too many proxies. So here you don't care, you just, if you measure that you need 50 Scylla nodes, then they will do everything. They do all the work, and you don't need to subdivide your cluster to all sorts of like roles and things like that. Of course, as usual in Scylla, so one node gets the request, but typically other nodes contain this data, and usually you even need more than one node because of the consistency level in replication. So all of this is taken care of internally. The client just needs to send its request to any node in the cluster. And because you need to pick one of these nodes randomly, usually you have some sort of either a DNS or an HTTP load balancer in front of this. So the client doesn't need to know about all these nodes, and it just picks one endpoint and connects to it. So this is the way the Scylla and Alternator servers work. And this is something I mentioned before, that the DynamoDB API it goes over HTTP or HTTPS, and both requests and responses have a JSON format. So you can see here an example. So the requests start with the header, and you can see one of the headers say that this is a create table request. And then this JSON says we want to create a table my tab. Like this is basically the same example we showed earlier with the command line. And you can see the response. This is the same response we saw earlier. It gives you back the table you just created, and also its status, its creation time, and also all sorts of other information in this JSON. So this is what the DynamoDB API actually looks like, but most users will not write these JSONs. You have, like I said earlier, you have libraries that give you Python or Node.js or whatever language you prefer, and it will send these requests for you. Okay, so now a short summary of if you want to go now after this talk, you like Alternator, you want to start using it, so you should know its current compatibility status with DynamoDB and its limitations. And you can see here I have two links where you can also later look at the current, at that time, situation. If you want to check in a week how it progressed, so you can go to we have a document about the compatibility and also a bug tracker. This is an open source project, so we have an open bug tracker. You can see exactly which issues we have opened and so on. So as I said, and even demonstrated live, we already have several DynamoDB applications that work simply unmodified. They just work. But there are some issues we still need to address before the general availability of this as a product. So I talked about the safe concurrent read, modify, write operations that we need to support with LWT. There are a bunch of like sub cases of various operations that we still need to add support for, because there are a lot of API requests and all sorts of sub cases.
And if you're not sure whether your use case works with Scylla right now, or whether you will need to wait for more capabilities to be added later, then you can always ask on the mailing list or on our Slack channel, describe your query, and Nadav or one of the other developers working on Alternator can tell you whether it is currently supported or when it is expected to be supported.
Yeah. So also we need to add support for authentication, like on AWS. and we want to add to make it a software as a service on Scylla Cloud, so it look like even more like DynamoDB, and other things like DynamoDB streams, which we didn't implement yet.
Nadav, there were a couple of questions. So before we go to the migration, what to answer them, and I'll toss them. Can you go back one slide before? So there was a question whether we support Dynamo Stream, and the answer to give you a lengthier answer is that right now we're about to ship change data capture for Scylla that gives the same basically functionality, but with a different API. So this will be more immediate, and only later on we'll try to impersonate with the same API for Dynamo Stream. So the first generation will be capture data change based on the Scylla implementation. Small comment about authentication is right now HTTP is supported without HTTPS. We're going to add HTTPS. It is possible to run it inside your VPC, so it'll still be secure. If you use the DynamoDB API, there's a question about multi-DC with Alternator. Nadav, would you like to take it?
Yes, so we don't support, so DynamoDB has a global table, a notion of a global table. So usually each table is local only to I assume you mean by DC, you mean different regions in
That's right.
Like that. So DynamoDB, the normal tables are local to a region. If you want to have a table across several regions, you need to make it a global table. So we don't yet support this syntax of global table, but actually what currently happens is that all the tables are basically global, because in Scylla, all the tables, if you don't do something special, so right now what will happen is that all the tables will be global, and we still need to fix exactly the correct API, because Amazon has a global table API to say which tables need to be global and which are not, and we need to fix that. But if you need global tables, then you actually have them already.
Right. So it's the actual data path is implemented for a long time in Scylla with multiple region, and of course we also support multiple zones too. Just to the API to create them global versus local isn't yet there, but by default you get globals. There is a similar question about backup, whether we support the DynamoDB API create backup command. And the answer is pretty much similar. So Scylla supports backups and supports snapshots, but we do not, we didn't implement and tie the API between the create API, the create backup AWS command and the Scylla snapshot command that triggers a backup. So it's not yet supported, but it's coming later.
Yeah, and you can see the link on top of this, the top of this slide, there's a link to something called alternator.md. And this has a full list of all the features. All these questions are answered there. So if you have more of these questions of what is supported and what is not, it's answered in this file. And of course, the point is that we are going to add all of these things. It's not going to stay missing for a very long time.
One last question that I received is whether we support conditional updates in the form of if A equals 1, then set A equals 2. And right now it's not supported, and you'll probably get an error with it.
So it is supported. The syntax is supported, but it's not, as I mentioned, it's not safe. It's not isolated. If you do two of these in parallel, then it just does a read and then a write. It's not. We need to add LWT to make these requests isolated. So the syntax is supported, but you shouldn't, if that's what you need, you shouldn't use Alternator yet, because it's not it probably won't give you the isolation guarantees that you need.
Correct. Thanks, Nadav, for correcting me. And if you're tuned to the ScyllaDB development mailing list, you can see the LGBT patches are going on. Last question is whether backup cause latency to the performance, add latency. And the answer is yes and no. It depends. Basically, you should when there is a backup. Usually, we create a snapshot, and the snapshot creation is cheap. It's just another hard link. Later on, those files need to be copied to another persistent layer, and we usually do that with S3. And we did go through in our backup implementation, the existing one on Scylla Cloud, which doesn't yet offer Alternator. We did go through many hoops to make sure that the backup doesn't increase latency, and we managed to control the bandwidth of the backup and make sure that also the backup use OR direct to make it as cheap as possible. And so it won't incur an additional latency. But of course, it's an additional work that the server has to do.
Yeah, but also, as I mentioned before, so we gave a lot of attention to the issue of latency. So obviously, if you do another thing like backup, it will take up some of your CPU power. So the throughput will go a bit down. But we tried very carefully to make sure that the latency doesn't go up a lot. I mean, it's not, it's deliberately, I'm not saying this just for the backup, everything. We have all sorts of other background things like compactions, repairs, things like that. So we try very hard to make sure that these don't affect the latency. And although they obviously have to affect the throughput because you're doing other work, we also have controllers which ensure that you don't do it too fast. Some of the things you have to do in the background, but you don't want to do them too fast and destroy the throughput of the system.
I don't want to take too much of the time here, but we have a great series of articles in our blog that describes all of these controllers and how we are able to isolate internal workloads and external workloads. And also we have the ability to isolate multiple user workloads so that if you have, say, an analytics job and an online job running at the same time, then you can isolate them so that the analytics job doesn't interfere with the online job. But I will refer you to the blog for more information on that.
Okay, so let's continue so we can finish. So if you like Alternator and you want to try it yourself and you want to migrate your application from DynamoDB to Scylla with Alternator, so of course you need to install Scylla. You can see instructions on our site or ask us, and you need some sort of load balancer to send a request to the different nodes. Or if you wait, you will also have this as software as a service eventually on the Scylla Cloud. And you should tell your application, instead of using the AWS, some sort of AWS region, you should give it the IP address and of this load balancer. And always remember that what we have now is a preview release. So you should watch out for the unsupported features and the unsafe concurrent read, modify, write operations that I mentioned before. But of course, we'll have general availability soon. I don't know how soon, but soon. And if you want to migrate existing data that you already have on DynamoDB and you want to migrate it to Alternator, we even wrote a migration tool written using Spark. And you can see here a link to the blog where we describe this tool. Okay, so that's coming to the end. So I want to summarize. So Scylla is a very efficient and reliable and low latency NoSQL data store. And we began with Cassandra compatibility, but the point of the Alternator project is to add to Scylla DynamoDB API compatibility. And the idea is that you want to run existing applications that were written for DynamoDB without any changes. You want to be able to run this on any cloud or any data center, and not, of course, not just on AWS, like original DynamoDB. And it's open source. In addition to having commercial support, it's also open source. You can look at the source, you can keep the source, whatever, all the usual benefits of open source. And I said that this is a preview release, but expect GA. Dor, you want to continue?
So we have many people attended this webinar. We hope to meet many of you at the Scylla Summit coming in November in San Francisco. We're going to have many more sessions like this with greater amount of details, more demonstrations, meet the entire Scylla team and a developer from worldwide, and meet plenty of users and customers that use Scylla for several years now, whether it's the open source, the enterprise, or the Scylla Cloud version. So, and we'll cover at the summit both the Cassandra API aspects and the Alternator DynamoDB API aspects, and also provide insights for the roadmap. So you're highly encouraged to attend that summit. Thanks. We have 3 minutes left to Q&A. There were a couple of questions that were asked about. One of them was about incremental backups, and Scylla supports incremental backups today, so it is possible. We'll need to tie it with the backup API of DynamoDB. We don't have a point-in-time backup at the moment, but all of the other backup options are operational and good enough. And another question about when is Alternator comes to Scylla Cloud, and that's indeed very soon. We'll start with the beta release, and later on, once we'll feel that we're ready for GA with the other aspect of database maintenance that we are responsible for them on the cloud, we'll ship it. Basically, the Alternator project is ready for consumption now, once you're aware of the advantages and the limitations. So go ahead and give it a try. And if you have feedback, we'd love to answer it on the mailing list or on the Slack. And we have a Slack channel, and now it's unified both for the Alternator and the Cassandra API together. I'm just uniting Q&A together. So it looks like we got to the top of the hour. So thanks everybody for listening. Thanks a lot, Nadav and Avi, and looking forward to meet you at the Scylla Summit, or to have you listening at the next webinar that we have, which is about, if I'm not mistaken, it's about collaboration with Confluent and one of our users that run it in production. I think it's a Lookout, if I'm not mistaken. So thank you, everybody. Have a wonderful day. Bye-bye.
Bye.
Thank you. Bye-bye.